What's Gucci, everybody? Woo! How you doing? I hope everything's good. It's about 2 a.m. here today, and it's March 1st. I want to say happy March. Yeah, that's about it. And today I want to talk about another type in C called booleans. And boolean is basically represents a true or false value. If you've taken any discrete math class, you've probably seen a boolean, probably heard of a boolean value or seen of an and, or exclusive or statement. Or really, it's something you kind of do every day in life. That's what's kind of great about programming, is it's really just advanced problem solving and problem solving that can do really big things. Which is why, if you've ever been on code.org, that's what they're trying to do. But Boolean is how to basically allow things to be displayed and allow things not to be displayed based on conditions in your program. And, well, let me show you guys an example. So right here, I'm going to write an include directory to include std.bool.h, this is saying include the standard Boolean header, and what this is going to do is basically allow me to use the Boolean value because my compiler is not in C99. Now, AJ, what the hell is C99? C99 is the standard in C that was released in 1999, I believe. And there's also the C standard 89. And basically, when they release new standards, they add in new keywords or make the language a little bit better or a little bit easier. And what they did in C99 is they added in Boolean as a type. So if my compiler was in C99, this bool variable would be purple, just like int, because it would recognize it as a variable type. But it is not, and instead I need to write in the include directive, which will make it a Boolean. So essentially here you see I've got Boolean, which I'm going to make a Boolean variable called I and say it's equal to true. I could also set I equal to false. Those are the only two values with Boolean. It's kind of cool, true or false. So definitely make sure that you know that. I mean, it's pretty easy. You don't have to worry about anything else. And what basically, I'm going to continue on a little bit more, but that's all you need to know about bool, is that bool allows you to be able to execute statements. And what I just wrote up is an if statement. And what an if statement does is it checks if a Boolean is true or not, and depending if it's true, it executes what's within that statement, and if it's not true, it does not execute. So I'm going to write if I equals true, and I know I'm showing a lot. I'll try to explain it over. So what's this saying? It's saying if I equals true, you need the double equals because a single equals assigns the value, as in line 7, false is assigned to I, but this is checking if they are equivalent. So it's checking if I equals true. Sorry. Let's see, I'm going to print out. Let me print out a string here. So I'm going to do %s is the command for printing out a string. This is true. I'm going to print this out. And did it print out? No, it did not print out. Sorry, guys, because obviously I said I equal to false. And because I is equal to false, nothing is printing out. I'm stupid. I should point this out. I should think about what I say before I do it. And as you see right there, my iPhone just went off. Hate it when people text me during videos. If I get rid of this statement, so I is true, the if statement will look, hey, is I equal to true? Yes, it is. So execute what's in these braces. You do need braces. It is good coding, and it does allow you to easily read what's in these braces. And note, if I copy this printf statement and put it here, it would execute this statement if I was true, and then it would continue on with the sequential coding. So C is a sequential language, so it first assigns this variable, checks if this if statement is true or not, and if it is, it executes what's in the block, and then it keeps on going. So once it gets out of these braces, it will keep on going. So me running this program will print this is true twice, and as you can see, this is true, and this is true. So there you go. As again I showed you, if I can also do if not equals. So what's this checking is the equals equals is checking if it's equal to true, but I can say if it's not equal. So what I is looking for is I'm saying I is equal to any other value that's not true. So if I is equal to something that's not true, I execute what's within these statements, within these brackets. And obviously I is true, so nothing is going to execute when I run it. And as you can see, nothing is popping up. But if I make I equal to false, this will execute. Now in Boolean, there's only true and false. But as you can see, but as I'll show you later, you can use these equality operators and not equal operators on such things as integers and chars as well. So there you go. You've learned the if statement. And what I also want to show you guys is that Boolean values can also be used as integers. What do I mean by that? Well, let me show you. So I showed you the type bool, which you need to import the STT bool if you're not using C99. Let's say I have an int I here, and I is equal to 0, and I just do I. Well, in C also uses integers as Boolean types. This is why Boolean wasn't defined until C99, and older types of C didn't have Booleans, because it used numbers as Booleans. And what C defines true as is any number that's not 0, and false as only 0. So I've signed I to 0, which in Boolean terms means that I is false. So what I'm checking here is I'm just going, hey, if I is true, I'm just saying if it's true, print out this statement. And I is not true, so when I run this, nothing comes out. Also, I could put an exclamation mark, which is a discrete math symbol for not. So I'm saying if I is not true, print out the statement. And I is not true because, as I said, 0 represents false in integer land. And as you can see, it printed out. Now if I made I 1 or made it 100 or anything that's actually not 0, I'll make it 5 just to show that it matters. Doesn't matter. This will not print out if I run it because I is true, and this is checking if I is not true. It's saying if I is not true, run this. But if I get rid of the exclamation mark, it's checking if I is true, I run the statement, and there we go. This is true. Most people define Booleans as ones or zeros. So it's 0 if it's false, it's 1 if it's true, just to give it a value. But I want to also note that, let's say I wanted to just make a statement that's always true. This really is not needed in programming, but I just want to show you, for example, I can say if 555, print this statement. Since 555 is not 0, this statement will always be true because it's not 0. So it's basically saying, oh, hey, if 555 is true, which it is because it's not 0, print out this statement. Now, if I could just say, oh, this is 0, it will be false and not print out anything because it's saying if this value is false, don't print out this statement, basically. And 0 refers to a false value, and any other integer refers to a true value. That's what you need to know. I could also check for equality here, again, so I can check for if 0 is equal to 1. Well, I say equal just remember that you need those two equal signs. You can't have just one equal sign, which obviously is false. This statement won't print out. I just ran it, nothing happened. But I could do the same thing with the not equal. So 0 does not equal 1, which is true. It will print out this is true. So as you can see, Booleans can be represented as integers or in the bool type in C99. That's all I've got for you today, guys. I hope you had a great day. I'll see you later.